So after you have this graph, make sure, and again, make sure your graph is graphed correctly. Make sure you've typed in this particular function right. And the only way you're going to be able to do that is to really just pay close attention. You know what the basic sine graph looks like. So if you type this in and you get a straight line, you know that can't be right, correct? You know sine curve is wavy. Now it's going to be distorted wavy. Also make sure with this t right here, whenever you type that in the calculator, it's going to be x, isn't it? Okay. And then once you have that, notice it asks you about speed, whether or not our speed is increasing or decreasing here. Is the particle of the speed increasing or decreasing? What two things must you check to know whether or not speed is increasing or decreasing? Do we remember?
Whatever has the same.
Okay, you're checking your signs of velocity and acceleration. How do you get to acceleration if you're given velocity? Take the derivative. So for A, we need to find both V at 4 and we need to find V prime at 4. Because if I take the derivative of V prime, or take the derivative of V, then that's going to give me my acceleration. Now, am I really worried about the exact value, or are we so much worried about the sign, right? That's what we're looking for. Now, after you have this function typed in, where can you go to just pull this up to keep you from having to type it in all the time? You go to var, right? Var is your friend, not bars. Bars will kill you, but var is your friend. Var is not. Okay, so if you type in and you get V at 4, V at 4, is that a positive value or a negative value? That should be a positive value. It's greater than 0, isn't it? And all you have to do is go back. Do y'all remember how to add a page? Control doc, isn't it? And you add a calculator page. Make sure you're not in the scratch work side, that you are in the document side. That way all of the pages are connected. Okay, what about the derivative? What about V prime at 4? Do y'all know how to get there? Yeah, and hopefully when you got there, you got a negative value. Did y'all get a negative value? All right, so what do we know about speed? Is speed increasing or decreasing? Speed is decreasing, so we're going to say speed is decreasing, and we need to make sure we tell the reader why we know that. Speed is decreasing because what? And you know, all you have to do is say, because you know that at V at 4, we were positive. And then what else? At V prime at 4, V prime at 4 was less than 0. And maybe up here where it says speed is decreasing, maybe we need to say at t equals 4. That would be a little bit better of a statement. That way we've really pinpointed. When you went through and looked at part B, you needed to find all times t on the interval from 0 to 3 that the particle changes directions. And you had to justify your answer. And that justification's always worth some points. So be careful with that. How do you know the particle changes directions? What can you go look at to help yourself find that? You go look at the graph, don't you? So let's make ourselves a note to look at the graph. Okay, once you look at that graph, you're looking at the graph, what do you need to go find? Okay, because you're looking at the velocity graph, right? You have the graph of velocity. How do you know a particle changes directions? Right, it's when you cross the x-axis, right? So on your graph, what are you looking for? You're going to find the zeros, right? So let's make ourselves a note there. You're finding the zeros. You find the zeros. Go to your graph, find the zeros. Now, you're not finding every freaking zero on that graph. Remember, this is a sine curve, so it's going to have a lot of zeros. But you're just looking from 0 to 3, right? Okay, so do y'all remember how to do that on your calculators? Yeah, how many times did the particle change directions? It's just once, right? Okay, so let's write out our statement. So let's see, at time, let's see if y'all found it. Get my pen working. So at t equals, and when I went through this, I found it at 2.707. Is that right? And what would be the time here? Did it give us a time, like as far as units? I don't see one. Do y'all? Okay, so at t equals that value there, we know the particle changes directions because, and so that's what we're going to write. The particle changes directions and why do we know it changes directions? Because what happens? What happens with V at t? Because V at t changes from what? It changes signs. It changes from what to what? I don't remember. Positive to a negative. All right. So because V at t changes from positive to negative, is that what y'all are saying? Okay. Positive to negative at let's see. No, I think that's okay. You don't have to put the word at. Sorry. It looks like that's okay. So it also would be a good idea for us when we found our zeros, let's go ahead and make the statement that V at t equals, no, sorry, not V at t, V at 2.707, right? That was where it was equal to 0. So V at 2.707 is equal to 0, right? Or you could say V at t equals 0 at t equals 2.707. But make sure that statement is done and then that you changed from positive to a negative. Questions about it? Any questions? All right, now part C, in my opinion, was kind of tricky. You're finding the position. How is the position related to the velocity? How are they related? Y'all don't be quiet on me. Velocity is the derivative of position. Well, dang. How are we going to get back to position then? We're going to have to, so we know somewhere along the lines, we are going to have to integrate, right? I've got to integrate V at t, dt. I'm going to have to do that somewhere, somehow, so that I can get back to position. Okay, well, I need some endpoints because I can't just blindly do the integral of velocity. We've got to have endpoints. What are we looking for the position at? At t equals 0. Well, do I know any other information about position? Right, look at the problem. We know the particle is at position 2 when t is 4. So if we integrate from 0 to 4, then we know we got something going on about our position, right? So let's go ahead and integrate that from 0 to 4. So you can go over to your calculate page and integrate numerical integral from 0 to 4 of your var. And when I did that, I got 5.8150. Right?
Yes.
But y'all have also told me, it's almost like this little integral here, it has a dual meaning, right? This right here, that 5 point blah, 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 that's the position at after we've gone from 0 to 4, right? So let's go back and look at our endpoints. Y'all also told me that if I integrate velocity, I get position, right? And so really this whole little statement right here also means that, well, if I integrate, I get position. And so with our position, we said, did we say X or T? I don't remember. It doesn't matter. They're the same. So let's say S just for grins. All right. So when I integrate that, I'm going to get S at 4 minus S at 0. When I get that, if I'm talking about strictly functions, that's what I get. Do y'all understand that? Do y'all see where that's coming from? I integrated velocity, I got position. And it's position and it's top endpoint minus bottom endpoint. Okay? That's also equal to this 5.8150 business, is it not? Because this is talking about the same exact function. Well, it's equal to this part, and then it's also equal to this other part. So those parts have to be equal to each other. Okay? So got some little transitive property going on from algebra. What am I looking for? S at 0. I've got an equation I can solve, don't I? I have an equation. What do I know about S at 4? It's 2, isn't it? So really, I have the equation 2 minus S at 0 equals 5.8150. Right? And we do have calculators. Don't try to be doing all this business up in your head. But, I mean, you can subtract 2 over, right? And change a sign. So, S at 0 is going to be negative 3.8150. Now, in Part D, ooh, all right, total distance. But total distance was a formula. Did anybody find the formula for total distance? It was on a little pink sheet that I gave y'all. Do y'all remember that big, ugly pink formula sheet I gave y'all? Right. Maya's got hers out. And there's also on your paths to 5, path to a 5. That's also there. Okay? It will give you your total distance. That total distance formula. Well, total distance is going to be found by doing the integral of the absolute value of v at t dt. That's all it is. It's the integral. Now, why are we doing absolute value? Distance is positive, isn't it? Okay. So I want to find the total distance from what to what? 0 to 3. And this is calculator, right? So this is all you have to show. This is it. Type it in your calculators. All right, so after you type that in your calculator, you just write it out. So you're going to get, when I did this, 5.3012. Does that kind of look like what y'all have on your calculators? All right, now all of this problem was a total of 9 points. That 9 points would have pushed those of you that made a 2, which was just about everybody in this room, that would have pushed you over to a 3. So do y'all see how important it is? You're going to see it somewhere. All right, so we have the graph of what? F prime. Y'all, when you get that AP exam and you have your free response, you circle, underline, somehow make yourself known. Okay, I'm looking from the point of view of F prime. I'm looking from that point of view. Okay, notice it also tells you that you are twice differentiable. So I would also underline that and say, okay, that also means that we are continuous. T-I-N-U-O-U-S. Yes. That also means we are continuous. Now, just because you're told you're continuous, can we assume differentiability? No. But the other way around, absolutely. You must be continuous before you can be differentiable. All right. So we have all of that. We're on the closed interval from -3 to 4. The graph of F prime has horizontal tangents at -1, 1, and 3. Has horizontal tangents. That is huge information. You will use every cotton picking part of the information. That's huge. What would I do? Go over there to that graph. What would Robertson do? Go to the graph, and we would draw in. I know I have horizontal tangents here. Why do I know that? Because they freaking told us, right? But what does that also mean? Which part of this? Does that mean F equals 0? Does it mean F prime equals 0? Does it mean F double prime equals 0? F double prime equals 0. That's what that also means, because it's the derivative of the derivative, right? So that tells me that F double prime, and y'all, on my paper, I would put this. I would read that, and I would mark up, every bit of this that I know. What happens when F double prime equals 0? It means we have a possible point of inflection, right? That graph is about to start turning. It's going to do something here. We also know the second derivative talks about concavity, doesn't it? So is it important that we know stuff about F double prime? Absolutely. That's why they gave us that information. It also gave us the areas of the region. Let's see, from -2 to 1 is 9. And then the other is 12. So before I've done any work at all, that's what my graph looks like. I encourage you to do the same. Groovy? Groovy grooves. All right. So now let's move on. Let's see if we can answer some questions now. Okay, find all the x coordinates at which the f has a relative maximum. And then you have to justify your answer. And this one was 2 points. So all of the x coordinates in which f has a relative maximum. Well, let's just go ahead and start with our justification, because to me, if we can recite the rule right then I can go look at the graph and grab it. When do I know f? If I'm looking from f prime, then f has a relative max. On the exam, don't abbreviate, but for class time purposes, I have to squeeze a lot of crap in a small amount of time. So f has a relative max when what happens? When what goes on? Tell me the rule. What's and it also equals 0. F prime equals 0, right? Because that's a critical point. We need to make sure f prime equals 0. And changes. Oh, I'm about out of room up here. And changes from positive to negative, right? Is that what y'all told me, positive to negative, right? Okay. Positive to negative. All right, so now I know exactly what I'm looking for, right? Okay, so what can we state here? This happens at, perfect. This happens when or at x equals, what did y'all tell me? -2. Did that occur anywhere else? No. You just earned 2 points. Yes, everybody can do that. I know y'all can. Okay. All right. Questions about it? Whoa. So for part B, on what open interval contained in from -3 to 4, so that's going to be our open interval from -3 to 4, is the graph of f both concave down and decreasing? Ooh. Concave down and decreasing. Now, we're talking about f, aren't we? Not talking about f prime, but we only have f prime to go on, right? So let's think through this, because when you see this question, you're going to be like, okay, what do I know here? Well, f is both concave down. Well, let's talk about concave down. When I see concave down, I know what has to be true. F double prime has to be what? Close, not necessarily decreasing, but negative. Okay, but f prime would have to be decreasing. Okay, so f double prime has to be negative. Well, based on just our f prime, when do we know f double prime is negative? F prime is decreasing. Does that make sense? Can we make that connection? Okay, so we're making that connection. Let's see. And then we also need to know, well, F is decreasing. So let's talk about F is decreasing. When what? When do you know that's true? F prime is negative. F prime is less than 0. How are we going to relate this? Now, I know F prime is decreasing. Well, okay, so I need to look where F prime is decreasing. And we also have to look to see, well, where is F prime less than 0? So that all translates to decreasing and below the x-axis, right? So where are we decreasing and below the x-axis? -2, and notice it is open interval, -2 to -1, and 1 to 3. Now in part C, you have to find all the points of inflection for the graph of F and give a reason for your answer. So let's start with the reason for our answer. Let's state what we're looking for. What rule would we use? Well, for us to have a point of inflection, the first thing that has to be true is F double prime must be equal to 0. Hey, I know that, right? I highlighted that on my graph. F double prime is equal to 0, and something else has to occur. We have to make sure we change directions here. We have to make sure we have a change sign, or sign change. So F double prime and F double prime changes signs. We have to ensure all of that happens. Well, F double prime is going to change signs from positive to negative or negative to positive. Well, it's changing signs when F prime is changing from increasing to decreasing or decreasing to increasing, right? Okay. What is all of that actually describing? Those horizontal tangents, isn't it? That just in a nutshell described every bit of those horizontal tangents. Because here, notice you had to change your direction, didn't you, there? So, where do we have points of inflection? So, we can abbreviate POI, that's okay. Point of inflection, well, that's going to be at x equals what? -1. X equals what else? +1, right? It's almost like we're making it too easy because it's right there in front of us, right? And what else? X equals 3. All right, questions about that? Any questions? What do we know is going to happen if I integrate the derivative? Let's just think out. Good. If we integrate, and I'm just going to leave this, let's say from A to B. I'm just making crap up. From A to B, F prime, right? F prime at x dx. If I integrate that, what's that going to give me back? F of x, right? And then if you evaluate it at your endpoints, it's going to be f at b minus what? F at a. And we've used that quite a bit, right? That's the idea we're going for here. So let's talk about maybe an integral that we could set up. Well, you're going to have to set it up so that you know something also about, well, if we are going to integrate, I've got to come up with an f at 4 value. So somewhere in here, I've got to set this up so that I have f at 4. I also have to set up another one so that I know a value for f at -2. So you've got a dual meaning going on here. What else do you know you are finding when you integrate? What are you finding when you integrate? Area under the curve. Well, do I know anything about area under the curve here?
Yeah.
Yes, you were given that, right? You marked it on your graph. So maybe we can figure out here how to put all of this together, okay? So let's go through. Let's see if we can't set up an integral over here. And I'm going to go over to the side so y'all can see a little bit better. All right, so we're going to integrate. And let's see. If we integrate, and gosh, we knew about f at 1, right? And we also know that the bounded area from -2 to 1 is 9, isn't it? So if I set up my integral to go from -2 to 1 of f prime x dx, what do I know that's equal to? Okay, yeah, you would know that f at 1, right, minus f at -2, but you also know that's equal to what else? And it's below the x-axis, so it is -9. So you also know that, don't you? Do you see how you can connect those two? Yeah? All right, so what do you know about f at 1? It is 3, isn't it? So I know that's 3 minus f at -2 equals -9. So let's go ahead and do all of this last part in our head. So f at -2 is going to be what? Positive 12. Positive 12. Y'all see how we did that? Yeah. Okay, y'all find f at, what's the next one, 4? Okay, so when I go to set this up, I'm going to integrate from what to what? Okay, so 1 to 4, right? F prime of x dx, right? What do I know that is equal to? What's one thing it's equal to? -12, right? It's under the x-axis. So -12, right? But we also know if we integrate the derivative, that's just going to give us back our function and evaluate that at our endpoint. So we get f at 4, right, minus f at 1. That's equal to -12. What value do I know?
F at 1.
F at 1, right? So I'm going to have f at 4 minus, what value was that? I can't see it. 3. And that's equal to -12, right? So what do we get for the value of f at 4? -9.